So today we will discuss about common salt. Okay, common salt. So in previous classes we discussed about neutralization reaction, right? So what is a neutralization reaction? A reaction between acid and base which gives salt and water. For this type of reaction we can call it as neutralization reaction, right? So in case of acid we are taking concentrated HCl, and in case of base we are taking sodium hydroxide. Then what will be the product formed? NaCl, right? NaCl and water molecule. So what is this NaCl? Sodium chloride. We can call it as what? Salt. Actually it is common salt. In kitchen we will use salt for cooking purpose, right? So what is the chemical formula of that salt? Sodium chloride, that is NaCl, right? So from where we are getting the sodium chloride? From seawater, right? So we can say that seawater contains so many types of salt. From this much amount of salt, we are separating this sodium chloride salt separately. Then we are using it for cooking purpose, right? And we can also see this salts in a solid rock type form. Okay, in some areas of world. Okay, so this type of solid salt rock we can call it as rock salt. Okay, the color of this rock salt is actually brown. That is due to the presence of impurities within that salt. Okay, so we can say that HCl, hydrochloric acid, on reaction with sodium hydroxide, we are getting sodium chloride and water, right? So this is acid, this is base, and we are getting salt and water, right? So the sodium chloride we can call it as common salt. Okay, actually we are separating it from seawater, right? And the seawater contains so many types of salts. From that abundance of salt we are clearly separating the sodium chloride salt. Okay, so along with that we can see some solid salts which are deposited around the world. Okay, so this solid salt deposition we can call it as rock salt. Okay, rock salt. The color of rock salt is actually brown. That is due to the presence of impurities. Okay, so that's all about this common salt. Okay, so we can use this common salt to produce so many products within the chemistry. Okay, that means we can say that from this sodium chloride we can prepare sodium hydroxide, baking powder, that means baking soda, washing soda, bleaching powder, like that. Okay, so from this common salt we can produce sodium hydroxide, and baking soda, washing soda. Actually this baking soda and washing soda is totally different, right? We are using these two chemicals for different purposes and the chemical formula is also different. Okay, and for preparation of bleaching powder. Okay, so that's all about this common salt. Okay, so from now on we can discuss about each chemicals, how we can prepare this each chemicals from this common salt. Okay, so first one is sodium hydroxide. Sodium hydroxide. Okay, so for this we can say that we can set up an experimental setup. So we are in this container, we are making into two parts by using a semi-permeable membrane. It is a semi-permeable membrane. Semi-permeable membrane. And in this one we are taking aqueous solution of sodium chloride. We are taking aqueous solution of sodium chloride. For this aqueous solution of sodium chloride, we can call it as brine solution. What? Brine solution. Okay, brine solution. Actually, it is aqueous solution of sodium chloride. Aqueous solution of sodium chloride, we can call it as brine solution. So, in this container, it is separated by a semi-permeable membrane, and we are taking brine solution in these two sections. Okay, so brine solution. Okay, and we are placing two electrodes connected with battery in this setup. Okay, so we are placing two electrodes. This is positive and this is negative. Okay, so this one will be cathode, this one will be anode, and this one will be cathode. Cathode. This one will be anode. Okay. So okay. So we can say that we are taking aqueous solution of sodium chloride in this container, which is separated by a semi-permeable membrane, and we are placing two electrodes which is connected with a battery in this setup. Okay, in this container. Okay, so this one is anode and this one is cathode. So this solution will contain what? Sodium chloride. That means Na plus and Cl minus along with water. That is aqueous solution of NaCl means what? NaCl plus H2O, right? That means it will contain Na plus, Cl minus, H plus and OH minus, right? So we can say that this NaCl contain Na plus, Cl minus. In water it will contain H plus and OH minus ions, right? So these are the ions present within this brine solution. So what will happen? Towards this cathode, which ions will move? The positive charge having ions will move towards this cathode, right? That means Na plus and H plus will move towards this cathode, and Cl minus and OH minus will move towards this anode, because the anode is having positive charge, cathode is having negative charge. That's why positive charge having ions will move towards cathode, and negative charge having ions will move towards this anode. Okay, so after this reaction, what will happen? Within this cathode, which gas will deposit? Actually, when Na plus NaCl and H2O react with each other, we are getting sodium hydroxide and along with the production of Cl2 and H2. Okay, that is, we can write it here. NaCl, aqueous solution of NaCl means what? Water, right? So when we are passing electricity, what will get? We are getting NaOH plus Cl2 plus H2. Okay, that means two gases are formed on this cathode and anode. Okay, so which gas is formed from this anode? We can say that it is chlorine gas. Chlorine gas is formed from anode, and hydrogen gas is evolved from this cathode. Okay, so chlorine is evolved from this anode and hydrogen is evolved from this cathode. Along with that, we have sodium hydroxide, right? So sodium hydroxide will be formed near this cathode. Near this cathode, what is forming? Sodium hydroxide is forming. So we can say that this part of this container will contain brine solution along with sodium hydroxide. right? Because sodium hydroxide is actually formed nearby this cathode. So within this brine solution, that means along with NaCl and water, it will contain sodium hydroxide also. Okay, so we can write it like this: brine solution with NaOH, sodium hydroxide. Okay, so that this is the experimental setup for the preparation of sodium hydroxide from NaCl, from the aqueous NaCl, or we can call it as brine solution. Okay, so this is the experimental setup. So when we are taking this NaCl and water, after passing electricity, we are getting sodium hydroxide, chlorine and hydrogen. Okay, so if you are noted this experimental setup, we can get into the reaction of this experiment. Okay, so now I am rubbing this one. So what is a brine solution? Brine solution is the aqueous solution of NaCl. We can call it as what? Brine solution. Okay, brine solution. Okay, so when NaCl